Hello, everyone, and thank you so much for joining our webinar on ocean energy technologies. My name is Josh Agenbroad, and I'm a partner at Prime Movers Lab focused on energy and climate-related investments. Prime Movers Lab is a deep tech venture capital firm investing in entrepreneurs and breakthrough science with the potential to impact billions of lives around the world. We're focused right now on 6 areas where we think deep tech innovation can have the biggest impact. And those are transportation, agriculture, manufacturing, infrastructure, human augmentation, and energy. And so within that last category, that's obviously the focus today, we've become very interested in ocean energy. And we were lucky to find Nicholas and have him join the team about 3 months ago and kind of lead some research into this area, studying the current landscape, the status of technologies, policy trends, challenges, and opportunities for ocean energy. We've interviewed many of the leading startups and experts from universities and government labs and test facilities, and we're lucky to have a really sort of interesting variety of those experts joining us today for the webinar. So thanks again for joining, and I'm really excited to be a part of the discussion. In just a moment, I'm going to hand it over to Nicholas to introduce himself and kick things off. And before I do that, I just want to take a moment to frame things up a little bit, how we got interested in this topic to begin with. So if I could sum things up, I think the 2 questions we've been trying to answer are sort of what if ocean energy could be harvested as easily as solar or wind power? And is now the time for us to diversify our renewables portfolio? And so like, if you think about the ocean, there's just an enormous amount of energy, right? Like tides. If you think about tides, the volume of water involved in those flows. Or if you've ever gone swimming in the ocean and been hit by a big wave, it's clear that the ocean contains just a lot of energy. And in fact, it's estimated that harvesting that energy in coastal areas, there could be more than enough power or enough electricity generated to power all of global electricity demand. But comparing with solar and wind, obviously, there's a big difference today. If you think about the enormous impact that solar PV and wind power have had in the world, it's kind of easy to forget that just 2 years ago, 20 years ago, sort of within my career, these technologies were 10 times as expensive as they are today. And if you looked at a pie chart of global energy supply, they really wouldn't even show up. But there were those who saw the potential for these technologies at that time. They started developing them into products, making them available for more widespread use, improving the reliability, improving safety, reducing the cost. There were policy makers who developed incentives to support early adopters, and then project developers who sort of got out there and started deploying capital, had to figure out those incentives and tax structures to make it work. And eventually we got into this virtuous cycle where economies of scale began reducing the cost of these technologies, allowing more learning, further improvement of the products, and reducing cost. And then that cost led to additional demand, and that additional demand led to further economies of scale. So it's this virtuous cycle. And today we're lucky to have a group working at sort of the early part of that journey for a new set of technologies. So I'm excited to discuss today ocean energy in that context, and maybe catch a glimpse of what the future might look like as we add some sort of new tools into the toolbox of decarbonizing our electricity system. So with that, let me hand it over to Nicholas to introduce himself and to kick things off.
Yeah, great. Thank you, Josh. I appreciate that. So my name is Nicholas May-Varas. I am a mechanical engineering graduate student at MIT, and I'm currently an ocean fellow here at Prime Movers Lab. And so as a brief agenda of what we'll be going through today, first we'll definitely hear from the panelists. They'll give a brief introduction of themselves. Then we'll have 30 minutes of questions and a conversation regarding ocean energy. And finally, if you have any questions throughout the conversation, feel free to put those in the chat. We'll be happy to answer those in the last 5 or 10 minutes or so. And so with that, I'd like to get started in introducing our panelists. And so I guess, Anthony, would you like to start, introduce yourself?
Sure thing. Hey, everybody. My name's Anthony DiMare, CEO and co-founder of Bedrock Ocean Exploration. We're building vertically integrated, hyper-efficient ways to collect data, particularly geophysical data about the seafloor itself. So think about sort of the shape, the composition, any of the geologic elements or ferrous elements that may impact your ability to do things on the seafloor. We've built robotics and cloud software to allow that to be very efficient. Background in mechanical engineering, naval architecture. This is my second startup. Excited to be here.
Amazing. Thank you, Anthony. Beth, I'd like to hand it over to you now.
Great, thanks. Hi, everyone. Beth Hartman, Program Manager for Strategic Innovation and Outreach in the Water Power Technologies Office at the Department of Energy. Previously to joining the Department of Energy, I was at Rocky Mountain Institute, RMI, for almost 5 years, where I focused on innovation in electricity and policy. And before that, I was at EPRI, the Electric Power Research Institute, where I helped build a clean energy incubator network in partnership with the DOE and NREL. So I have a lot of experience in technology innovation and commercialization in energy generally. So at the Department of Energy, the Water Power Technologies Office sits under the Office of Energy Efficiency and Renewable Energy, along with the wind, solar, and geothermal offices. So just to give you sort of a picture of where we sit. And we focus on both hydropower and marine energy. So anything to do with energy and water. Obviously, today we are focused on the marine energy side of things. So I'm excited to get into the discussion.
Awesome. Thank you very much. Marcus, could you please introduce yourself?
Yeah, hi everyone. Mark Seaman, co-founder and CEO of CalWave Power Technologies. We're a San Francisco Bay Area-based technology developer. Our vision is really to unlock the power of ocean waves and mission to become the provider of most reliable and cost-effective solution to harness that enormous amount of power. We had a successful trial in 21-22, 10 months continuous deployment in Southern California and San Diego, and are now working on a longer 2-year pilot in Oregon at the new 20 megawatt wave farm funded by the DOE. We are really excited to dive into the session.
Awesome. Thank you, Marcus. And last but not least, Anders, would you like to introduce yourself?
Thanks. Yeah, Anders Jansson. I'm head of business development at CorPower. We are a Swedish headquartered wave energy company. We are a turnkey OEM to deliver wave energy technologies. We've been developing this since 2012, when the sort of primary inventor, who was a cardiologist, saw that the pneumatic pretension in the heart could be used in wave energy technology, which was kind of a step change on how you could radically change your ability to be in or out of phase with the incoming waves. And we've since then been pushing this technology. We're now about 80 employees. We raised closer to $70 million. And we are what we call in that final stage of demonstrating the technology to bring it to a bankable technology, enabling project developers to start building hundreds of megawatts of this type of technology. I've been in the sector since 2006. I co-founded a tidal energy company, which we put on the First North NASDAQ stock exchange in Stockholm in 2015. And then I moved into wave energy and CorPower because I believe that we have sort of cracked the code of both being able to survive the big storms and at the same time be able to produce cost-efficient electricity that can compete head-to-head with any other type of energy production. Thanks.
Awesome. Thank you, Anders. And so with that, I'd like to start getting to some of the questions. And so I think I want to start a little broad and kind of, as Josh was referring to, wind and solar have definitely decreased over the past 20 years in cost. So I want to kind of discuss and get your opinion on why marine energy, why is marine energy important now? Why do we need wave, for example, wave and tidal? And how can it complement some other renewable energy sources? And so I'd like to kind of open the floor to anyone who would like to start.
Maybe I can start on that, since coming, both from wave and tidal sectors. I think, first of all, why is it needed? When we look at where we are now, we can see that we can certainly produce the amount of electricity that we need with solar and wind, but that is not the challenge anymore. It's about producing 24/7 reliable energy. And tidal is, really predictable. We can set the clock after the tides, and we know that, 100 years in advance almost. But it is intermittent but predictable. Whereas wave is a way of storing wind into the ocean, and you can have several weather windows out in the ocean where the wind gets accumulated into the waves, and those waves hit the power production differently to the wind. So you have a very complementary production profile, which in a way you can say it's the largest storage unit on the planet. So this complementary effect then means that we can reduce the total installed capacity needed, and at the same time then reduce the total cost of the energy system. So I think that's the sort of primary reason why we need wave and tidal.
Yeah, I'll echo that, Anders. Thanks. That was a very good overview. And then also just kind of reinforcing the points that Josh made earlier, solar and wind used to be very expensive, but then the more you build, the better we get at it through learning curves and economies of scale. So these solutions can scale and become cost effective. And I think it's a really exciting opportunity right now to learn more about it and get into the ocean energy space. Another great thing about ocean energy, aside from helping to balance out other sources of clean energy on the grid and the enormous potential amount of energy in the ocean, is that it's near a lot of people. A lot of people live near the ocean, on the coast, in big cities or in small remote communities, and so it can add a lot of energy into the mix for many, many people around the world.
Yeah, maybe complementing that, us being here in California, where we have the duck curve, so the big challenge of essentially solar coming offline in the evening, a lot of people coming home, turning on their lights, now charging their EVs. So that big problem of bridging the daily, but then also the seasonal gap of production. They've considered turning, I think, the Hoover Dam here into pumped storage, which would solve the problem by, I think, a tiny margin. So what a lot of people don't know, that the electric grid, you say, it's a big problem, but if you don't actually look into the numbers of how much storage it would take to fully decarbonize the grid, these are like large zeros, so 3, 4 zeros, multiple behind the storage we have today. And so the more renewables we put on the grid, the harder that problem becomes. And I think it's great to see wind and solar progressing so fast, but there will be its limitations. In California, I think you cannot install solar without storage anymore by mandate. And so, exactly, that stability is one big feature. Another big element, and the International Panel on Climate Change pointed it out, is from a total life cycle emissions perspective, just working with a resource that is 20 to 60 times more energy dense ultimately leads to the lowest source of clean energy from a life cycle emissions perspective. So the IPCC really has forecasted that. So the amount of space we need, for example, compared to an offshore wind farm to get to the same rated power is in the order of, only 5 to 10%. So as space becomes limited, working with a energy dense resource is really attractive as well. Next to we get it delivered to our front doors here, and no long transmission lines from the center of the country to the coastlines, where I think the stat is always 50% of the US population lives within 50 miles of the coastlines. So that's where also majority of migration is towards the economic centers and trade centers on the coasts.
Mm-hmm. And I just wanted to give a shout out to Pump Storage Hydro. Since you mentioned it, Marcus, I know we're focused on marine energy, but a lot of people don't know that over 90% of the storage on the US grid currently is provided by Pump Storage Hydro. So batteries get all the attention, but everyone forgets about water power. So I'm just really excited we're talking about it.
I think it's an important point when you start looking at marine energies. It has been spent fairly little money into this sector. And I think we're now getting into maybe third or the second or third generation of type of technologies. And historically, what we have seen is that either technologies have broken down in the big storms, or they just haven't been cost efficient. But what we see now is when we start looking at the structural efficiency, meaning how much material is needed to produce a certain amount of electricity, we are now at the level of offshore wind already in early generations of wave. So if we can produce even more energy, but with less material, that means that the cost levels are coming down quite fast. So I think that there is a big step change in the maturity of the technology that we see today compared to what maybe we saw 10 years ago. And that is the biggest reason why marine energy is getting really, really excited, and we can see more and more actors getting involved into it.
I have also something to add that I think is sort of tangential and overarching across all of the renewable energy sectors, but particularly in the marine energy space is, as Beth was saying, the vast majority of the demand is very close to shore. And the grids that we have set up on land are meant to be able to turn on a coal power plant when you need more energy and turn it off when it's not there. In many ways, we need to create, at least what we're seeing is on top of the ability to create redundant grid systems on the seafloor that connect different areas, allow balancing of grid and electricity between different coastal areas. For example, the UK is creating a completely redundant grid system all around the entirety of the UK to be able to trade energy between different areas. That will need to be supplemented with offshore wind, which is sort of the predominant ocean renewable that we're seeing today, but mainly because of its maturity. But then subsequently, we don't have the capacity to store all of this energy and meet that sort of the demands that we're seeing. So from at least the seafloor only perspective, there's a ton of infrastructure that needs to be built, solve some of the sort of grid balancing problems, and all of that has the opportunity to sort of interface with all these new technologies in a completely novel way where you don't have to maintain the old infrastructure. You actually just get to build the infrastructure that you otherwise would have wanted to do in the first place. So that's exciting from our end as well.
So thank you everyone for those great insights. I appreciate it. So now I guess we have like why now. It's definitely important, but also I want to get into a little bit more about the technologies. So I just want to discuss what is the current status and also what some applications of these technologies. And so let me, I guess, premise that. So there is research being done like remote communities or island communities, as well as grid scale. And then also this idea of the blue economy where powering devices at sea, whether it be sensors. And so I just want to get your insights about what do you see as some possible applications? And then also specifically what technologies are you developing that could enable those applications?
Yeah, I'm happy to jump in here. So I think another exciting thing about ocean energy, in addition to its enormous potential to generate electricity, is that there are other applications that are very useful, like desalination, ocean observation, aquaculture, marine carbon dioxide removal. And so we have seen these solutions work. We had a prize opportunity called the Waves to Water Prize that demonstrated that wave energy devices can produce fresh water. So it's kind of a fun thing to do to use the water to produce fresh water. We also have worked in the past with a company called Carbon, doing some research out with the Pacific Northwest National Lab and NOAA, and I saw that they recently raised $20 million for marine carbon dioxide removal, which I think is pretty exciting. And then another thing I'll just give a little shout out to is that if you do want to test a wave energy device for generating electrons in a commercial way, we are going to be opening a facility very soon called CalWave, which is up in the Pacific Northwest, and it is a pre-permitted site for wave energy technologies to test their devices in the water, connect them up to a big cable that connects to the grid. And so just felt like I had to give a shout out to that. And I know that Marcus, you're very familiar with our work there.
And maybe happy to directly follow up on that. Yeah, we're very familiar with the site. We've been designing for CalWave since 2019 under a DOE award we've won there. Initially, our technology comes out of UC Berkeley and the Lawrence Berkeley National Lab. We got support there from a program called Cyclotron Road, or now Activate. And our solution operates fully submerged, and that allows us to really meet the same criteria from a fundamental architecture perspective as the modern wind turbine, being high performance and ability to autonomously shut down in storms. So the wind industry really became industrially scalable when pitch and yaw control was introduced. So the ability of wind turbines to really shut off by themselves. And so, yeah, being submerged allows us really to mitigate loads in big storms, and that keeps the capex low. All the pretty large loads you would get from the 50-year storm for offshore wind or any offshore structure, you have to design for the 50-year return wave, because that's what the banks and insurances want to see. And so, yeah, of course, you want to be careful that that wave doesn't become your cost driver, but barely contributes to your average energy production throughout the year. So that's really a challenge that the industry was facing so far. And yeah, new technologies coming to market now really have addressed that. And then we went through a nationwide competition called the US Wave Energy Prize, hosted by the DOE and yeah, the national labs, and did extremely well there. Out of 92 teams, made it to the top 9 companies that were tested by third parties. So it's really the first time that in a standard testing environment or standardized conditions, a third party recorded performance, and yeah, our solution then achieved the highest performance there. And as a follow-on to that prize, first and the second scoring companies won awards to do an open ocean pilot. So we've conducted that then in San Diego last year for 10 months. Yes, I've been out for initial target was 6 months, but yeah, we had 0 downtime, 0 intervention. So we extended the deployment to 10 months, and yeah, we're operating fully autonomous for 9 out of 10 months. So really demonstrated from performance to reliability and survivability, and especially the autonomy enables us then also to scale similar to offshore wind.
I think it's, I mean, the wave energy sector in particular has been very diversified when it comes to types of technologies. And I know that has been one of the big challenges for investors to know, well, what should we go? I have 50 different types of technologies. Which one should I pick? I think we're seeing more and more merger to these type of point absorbers, which I think is good. And when you start looking at the application and the different verticals, there will be, I think, a number of different applications. So you have the smaller scale with smaller electricity needs, sensors, subsea, aquaculture, etc. But you also have the utility scale. I think that's where we see most of the interest now, is the drivers behind getting to 24/7 renewable on an hourly matching. So, we have a number of big data companies saying that, we want to match the electricity production with the consumption every minute all over the year. But we also see some industrial companies who drive that as their sustainability sort of target, which is where wave energy really can play a significant role. So we've done studies for a big hydrogen facility, for a green steel facility using hydrogen, and we could decrease their installed capacity with approximately 46%. So going from about 8 gigawatts of installed capacity with solar and wind to 4.4 or 4.5 gigawatts of installed capacity, which is massive. And still, even though that was an NPV calculation, and it picked up about a gigawatt of wave, because we are twice the price in 2030 than onshore wind and solar, it really tells you how important those different production profiles are and how massive impact it has on the overall energy system. So I think there will be a variety of applications, but basically it comes down to, we need electricity at all times. It's very hard to shut down, and that's where marine energy will play an important role in the future.
I probably have one more also fairly macro state, that I'm not an expert in any particular singular energy source, but I can tell you from what we're seeing on the different nations or island states or countries that are looking to understand where they could be deploying renewable energy in general around the ocean, which is sort of where we come into the picture. We're seeing everything from the smallest islands who want energy independence all the way up to the largest nation states who, control the world. And so no matter who they are or where they are, there is a very clear desire to understand where they should be allowing companies to deploy this energy, just because of the cost profile and frankly, how much easier it is to deploy in comparison to some of the more land-based solutions where they may not even have the ability to do it in some cases. So we're seeing up and down the spectrum of size of demand, from just trying to figure out where and how they should be looking at things. Power to X in general is a really exciting concept. For those that don't know, Power to X is you generate electricity and you do other things with the excess electricity, whether it's hydrogen production or desalination or all sorts of different things you can do. So this is all very exciting from our perspective.
And I think the latest COP was also picked up that the industrialized nations now putting a large fund together for the small island development states to become energy independent, reduce their carbon footprint. Yes, along these lines, there's a UN initiative called Go Carbon Free 24/7 that we just joined. Yeah, exactly highlighting the need there for the 24/7 nature of it. Yeah, it's all really good progress, but it shows up on the later end. And of course, we wanted to accelerate the adoptions early on with the low-hanging fruits. But I think as we progress with more renewables on the grid, that's where the stable ones really start to stand out and be critical.
Exactly. Awesome. Thank you very much. And I guess going back, Anthony, because your company is I see as a kind of a key enabler of all these technologies, wave, tidal, even offshore wind. I was wondering if you could share a little bit about how more specifically, how your technology could accelerate this industry or other industries entirely.
Yeah, so one of the big challenges, regardless if you're doing wave, tidal, offshore wind, regardless of whatever infrastructure project you're trying to actually make happen or possible out in the ocean, is you kind of have to understand what the geophysics of the seafloor are. You usually have to anchor them to the ground somehow. And you almost always, at least to my knowledge, have to run a cable back to some grid in some way, shape, or form. Oftentimes you'll have arrays of cables that connect different parts of the renewable farm, or I'm assuming different parts of the wave energy system. That all comes back to some very large substation, which is a very, very large piece of infrastructure that you have to you have to plan for the 50-year storm. So being able to have access to as much seafloor information, and particularly geophysical seafloor information, anything that you could use to imagine building a foundation in a dynamic environment that is always changing with tons of current. The way it's done right now is with very large ships. It's usually procured after the fact of a lot of capital being deployed, for better or worse. And so what we're trying to do is move that data into the hands of people much earlier at a different cost structure, over larger periods of or larger areas in much less time as well as cost for individual contributors. In other words, don't put all of the risk on just the developer, help spread that out across different parts of the value chain. Everybody's trying to assess risk of when they think about how they should be deploying their resources. Are they being appropriately designed? Are we looking at the ROI of these projects correctly? Are we doing power purchase agreements at the correct time, at the correct price? What is the ultimate LCOE, which is driven by the ultimate construction cost and then maintenance of those projects over long periods of time? All of that requires seafloor data, surveys, or monitoring, whichever you'd like to call it. But either way, we need to find much more scalable ways to do that right now. And so what we're trying to do is get ahead of a lot of these different technologies and where we think they're going to happen, and be able to actually go out, have that data already on hand, and then be able to provide that to different companies at a dramatically reduced price in a much faster period of time. And so that's one of the bottlenecks right now for being able to actually develop things quickly, is, for better or worse, there are requirements, either it's from governments, environmental regulations, all sorts of different things that require a deep understanding of what's actually going on. And I generally think that's a wonderful thing, and we should be doing that. However, the ways that we've been doing it in the past just don't really scale as effectively. And as we're thinking through the massive amount of area that is now needing to be surveyed, because we've got offshore wind, we've got wave power, we've got tidal coming in, we have all sorts of different grid HDVC lines that need to get put in place. We're finding that the amount of area that needs to be covered within the exact same year is growing exponentially, and it's we can't grow our survey fleet that quickly. And so we need to find supplemental ways to provide that data, and ideally it's done in a more economic and environmentally friendly way. And so that's mainly what we're trying to do here at Bedrock. But we're just the ones that say, listen, you would never go buy a property or a house without doing a survey of it beforehand. We're the survey. They're the ones that actually are doing the construction and help sort of make the renewable energy itself happen. So we're a supplemental both enabler and monitoring service long term as we think through how to maintain these assets over 30 to 50 years.
No, thank you for sharing that, Anthony. And kind of going off of what resources are needed. So we definitely need data. And also I want to kind of get into more the governmental, the policy side of things. And so I guess what my question is what government support is needed, or do you feel is needed to accelerate the marine energy industry? And so there was an Inflation Reduction Act as well as the bipartisan infrastructure law. So I was wondering, I guess, Beth, you probably have a lot of familiarity with this. Could you provide some insight of like what advice would you provide companies regarding these or other policies that are being developed?
Yes, certainly.
Excellent. Thank you.
So there certainly was already plenty of government support, not plenty, but government support available for wave and tidal energy before the Inflation Reduction Act and the bipartisan infrastructure law were passed. Our two favorites, Uncle Ira and Uncle Bill, certainly did increase the amount of support that is available. Guidance from Treasury is still continuing to come out in terms of specifics on how you can take advantage of the production tax credit, the investment tax credit. There's a lot of additional bonus money you can get for domestic content and prevailing wage. So basically, if you do projects using stuff built in the US with US workers who are getting paid well, you get more credits. And we have a whole webpage on our website outlining the different types of credits that might be available for hydro and marine energy. So just energy.gov/water, or you can Google like Inflation Reduction Act opportunities for hydro and marine. Please check it out. And then on the bipartisan infrastructure law side, we just released a funding opportunity a couple of weeks ago that is $45 million funding opportunity for tidal and current energy solutions, which is the largest funding opportunity that we have ever released in the marine energy side of the Water Power Technologies Office. It is designed to encourage construction of tidal energy projects here in the US. Those already are working in many places around the world. I think some examples have already been mentioned, like Orbital up in Scotland. And so we would love to see some deployments happening here in our country. And I guess if I had my top tips for if you wanted to apply to a funding opportunity like that would be to start now. It's kind of a long, arduous process, and then think about who you might need to partner with. The opportunity is open to non-US entities, but you do have to partner with the US organization as the lead on that. So get started now and think about who you want to partner with. There is a ton of money available, and it just seems like more and more guidance is coming out every day. I know we've already mentioned hydrogen a few times, but there's going to be more guidance coming out on the hydrogen production tax credit and who qualifies for that. So stay tuned and get moving as fast as you can on whatever is clear.
Amazing. Thank you for that advice, Beth. And I kind of want to open up this question is kind of for anyone, I guess. What are the biggest challenges of marine energy? So we talked about some definitely harsh conditions, but what are some other challenges that you would see within this sector, both technical, but also just societal or governmental, and also more, I guess, also importantly, how you're working to overcome those challenges within your organization or company or things like that.
I can
I
probably
can start. Oh, sorry. Yeah, go ahead, actually.
feel free.
All right. Well, looking at how to develop new energy technologies, I use been doing it twice now. I say it takes about 10 years and costs at least $100 million to do it, to get from original idea until you have a bankable product and creating revenue. So if we talk side of the typical valley of death, it's quite long for these type of companies, and that's where governmental support becomes crucial to sort of balance that risk for the early stage investors. And then you get into building the first projects, and then you're getting into the challenges of bankability, insurance, warranty. And that's also where we are working quite a lot with different governments to sort of look at different type of warranty funds, where they could potentially underwrite or give support to underwriters for the projects. So we have, for example, the European Investment Bank, we have a Swedish export credit that we can use there to sort of lay the puzzle on how you fund the first projects to get going. So that's, I think, is probably our biggest challenge at the moment, is to get through that in a reasonable timeline so we can start building the projects and create revenue to the company. So that's on the commercial side. And then when you get into technologies, is obviously, time in the water is what counts. That's how you decrease the risk. That's how you get insurance companies to feel comfortable with you and go through all the certifications, which is something that engineers tend to really enjoy, is to go through those hundreds of documents and write down everything they do and why they do it and how they do it, and ensure that following all the standards. But it's needed, and I think that's also a big shift in this sector, where it's no longer naive and thinking that as long as you just have a good technology you can sell it. It's actually about, you need to convince the banks. By the end of the day, that's who you need to convince, so you can create a market for yourself. And the only way to do that is to decrease the risk.
So I was actually going to pose a question to both Anders and Marcus here of, have either of you had experiences around trying to submit, a COP or a concept of operations plan to the Bureau of Ocean Energy Management? Has that, and that's a US based entity, of course, so that's not a globally based, but have you been through that experience? From my understanding, it takes quite a large team to get those built and just even submitted, let alone approved. So I'd be curious to know what you guys think. We're just one supplemental data source that is added into those, if it exists. But I know that from what I've heard, that they can just take a while, and the Bureau of Ocean Energy Management is, I think, understaffed right now and is swamped with all these projects, and they're moving as fast as they can. But that's one side that I've seen. I'm just curious what you guys have experienced trying to get government approval to deploy even test units.
Yeah, happy to comment from a US developer perspective. For our deployment in San Diego, it wasn't a commercial deployment, it was a demonstration, and we collaborated with the Scripps Institution of Oceanography, their UC San Diego, where initially we're coming out of the UC system. That's when we actually started the collaboration there. Yeah, so we needed 9 different permits to deploy there and recover everything at the end. But yet there wasn't a BOEM specific permit. I think BOEM comes in then in federal waters. So for offshore winds, a lot of the lease areas are being sold off, auctioned off by BOEM. And with CalWave also being fully pre-permitted, that actually takes off a big burden on our end. That, we don't want to become a project developer. We want to become an OEM, provide the equipment to project developers that have that expertise. They know how to source the project financing. That's really their core bread and butter. The big, offshore wind project developers, they usually buy the wind turbines. So similar, we want to become the provider of the wave equipment. And so our hope is that, BOEM will also incorporate other sources of marine energy into the umbrella leases for offshore wind. So we're seeing now the White House actually just published the Ocean Climate Action Plan that includes offshore wind and wave and tidal. So I think, similar trade associations that used to solely focus on offshore wind are now widening their horizon, adding other marine renewables or ocean energy to that. And so, our hope is that we can leverage existing permits, existing projects, even down to the existing infrastructure, even the cables and substations of an offshore wind farm that have access capacity and can complement that with wave going forward. So that's a way to accelerate market adoption there with industries that are already up and running.
I just wanted to give a further shout out to that White House Ocean Climate Action Plan. I think it's a really good plan. You should take a look at it, and it's grouped into the 3 key buckets, which is not only producing more clean and electrons, but also removing carbon dioxide from this system using potentially marine carbon dioxide removal, and then increasing resilience for communities that will be impacted the most severely by increasingly severe impacts of the climate crisis. So check it out.
I think the question is hugely important, and I developed commercial projects in the UK, and it's quite a bureaucratic process. But in the UK, they have a process, so you know what you need to do, which is good. But it takes a long time. It takes about 10 years to develop a project, which is not preferred when you're a small developer and chasing revenue. In other countries, you have different processes and it can go much faster. But here is probably one of the biggest sort of obstacles to quickly roll out renewable energy in any country in the world, also in Sweden, is the long lead time it takes to get to consent and the high risk of the project developers role of waiting 5, 7, 10 years to get to commissioning. So I think it's been recognized by, I would say, most governments, but very few has done, in my view, enough to lower or enhance the speed on how you can get to project initiation to final consent.
Yeah, I've seen more interest recently in accelerating the permitting process for hydropower in the US. So maybe it will wash over into the marine side of things as well. Who knows?
We've also seen that in the offshore wind space. They're trying very hard to accelerate that. And I would assume that would then translate into tidal and waves. So I think offshore wind's probably getting the blunt of it right now, because everybody under the sun is trying to get gigawatts built within the next 10 years. And they're just looking at the reality of the permitting process itself and saying, if we don't change this, we don't get what we want. And so I can say from the United States side, that's certainly what's happening. I know parts of the EU are looking at it as well. I don't know how that's advancing, but I think what we're seeing, at least from the extreme increase in desire over the last 3 years in offshore wind globally, is going to open up doors dramatically for all of these other tangential renewable sources, particularly from the regulatory side. And then hopefully, particularly in like Bedrock's case, there will be readily available maps of all of these things and all of these lease areas, or at least that's the goal. And so being able to have all of that already done, already set in place, takes a huge burden and reduces a ton of the bottlenecks that I think anybody would have to go through to deploy any sort of infrastructure, renewable energy, a hydrogen plant. There's all sorts of things they're looking at deploying out just 10 to 20 kilometers offshore.
I was just going to compliment that. In California, they just auctioned off, BOEM auctioned off 2 larger lease areas for offshore wind in Northern and Central California. And so I think they're working on accelerating the permitting process now that the leases are sold and, people want to start developing projects. So that's being acknowledged. And as you pointed out, there could also be opportunities where you don't have to go the utility scale farm similar to offshore wind level, but deploy alongside existing assets. There are platforms out there. We've heard hydrogen production. Some of them have dedicated pipelines that could send ammonia or hydrogen back, or even behind the meter with corporate PPAs with, let's say, food producers, coastal communities, islands, that you don't have to build a large 50, 100 megawatt level farm, but can still be attractive decarbonization targets there.
Anthony,
Maybe I could.
Oh, sorry.
Go ahead, Beth.
I just wanted to flag, Anthony, that we also released a marine energy potential study in March in partnership with NREL and PNNL and I think Sandia. So there's a lot of government tools also to help assess where these projects might be best located.
I was going to change gears just a little bit away from the sort of government and regulatory side and ask about the cost side of the equation. And I was wondering if you all could talk a little bit about where are we now with the cost? I mean, maybe the first thing to say is like, how do you measure cost? Where are we at today with the cost, and how does that compare with where do we need to be for early customers, and then also for scaling up? And then the second part to that question, which I think will be really interesting from this group in particular, you know, there are a lot of reports out there that have like cost curve projections, but you all know very concretely, you have detailed sort of bottom up techno-economic models. What are the opportunities to bring down the cost? How does that happen in practice?
Yeah, I mean, for us, we've been doing quite a lot of studies with different partners to really understand the value. So we like to, and I think that it's picking up more and more. It's like, okay, we've been focusing on LCOE. It's been really good with the different CFD auctions or feed-in tariffs and competitions to bring down the LCOE of solar and wind. Whereas now we're seeing that there's a need to focus on the levelized value of electricity, meaning what's the value to the market? And you have something called capture price, which is, well, what's the value? And what we're seeing in most countries in Europe with fairly high penetration of wind is that Wave has about twice the capture price of wind. So we did a big study last year with one of the big consultancy companies who came to the conclusion that at 70 euros compared to 35 euros of wind, onshore wind, you can compete head to head with wind. So we have 70 euros or $70 as the sort of, okay, that's the first step that we need to get to. And we think we can get there when we have installed about 600 megawatts. So fairly little amount of devices needs to go into the water to get to that point. If you compare that with the floating wind, they expect to get 70 euros after 3 to 5 gigawatts. So we can get there 5 to 10 times faster based on a number of things. One is the structural efficiency we talked about before. So that's the amount of energy we can produce with a certain amount of material. Second is the higher capacity factor that we have. So you can produce more electricity over a year with the same installed capacity with wave than you can with wind. And for that reason, we think we can get to maybe $30-35 per megawatt hour is sort of after a few gigawatts have been installed. And that is by far going to be very competitive. And if I'm being extremely sort of bold and saying, okay, what we're going to see in 20 years, I think that a lot of the floating wind sites are not going to be developed as floating wind. They're going to be developed by wave because you're going to have at least the same LCOE, but you have a higher capacity factor and you have a much more steady production profile. So obviously I'm very biased in this, but when you look at it, it kind of makes sense that if you have a more steady production, higher capacity factor, same cost, you're going to choose that instead of something else. In the meantime, I think we're going to see a lot of co-location, meaning that you can combine floating wind and offshore wind with wave in the same area. So you have a much higher density per square kilometer or hectare in wave than you have in wind. And wind power plants need to stand very far apart not to disturb each other. So you could co-locate these, use the same DevEx cost, what Anthony talked about, the cost of developing the projects can be shared, and then the same electrical infrastructure and the same, and a lot of the operational expenditure. So there was a study done by something called Wave Energy Scotland and a consultancy company, OWC. It was announced maybe 2-3 weeks ago, where they have done detailed economic studies saying that co-locating can reduce the LCOE with approximately 12%, which is massive. I mean, 12% in energy is a lot. They're now changing, 0.5% is currently quite big in wind. So that is for sure what you're seeing now is co-location is getting on governmental targets. It's being not only LCOE auctions, it's also the qualitative additional value that you bring that's going to be part of the auctions already in the coming years.
And to complement that study that found 12% wind LCOE reduction, also showed 40% LCOE reduction on wave by co-locating. So very much agree with what Anders said, and these are all costs and opportunities. There was a study by University of Oxford that actually looked backwards on the cost declines of wind and solar, because as you pointed out with volume, there are always these standardized learning curves, and people usually say it's something between 6 and 12% is your learning rate. For solar and wind, they actually found historically it's higher. It was 20 to 30%. And so if you take these learning rates, the need and the push for climate solutions, and combine that with a very energy dense resource, then one might wonder why should it not get as cheap, if not cheaper, than offshore wind in the long run. But yes, Anders pointed out, the challenge will be how do we get to volume? How do we get the first 100, 500 units built and financed? So I think once we're over that hump, then it will really become very attractive and a no-brainer for the developers.
I should also flag that there are other offices at DOE that have more money than WPTO, like the Office of Clean Energy Demonstrations or the Loan Program Office. So there's lots of ways to get government money that can also help to make your projects potentially more bankable.
I have a big question that I think a lot of people, when they think about tidal and wave, don't necessarily know. So I'd just be curious if both Anders and Marcus have any insights into this, is the sort of long tail cost, the operations and maintenance phase of all of these different projects. We know roughly what it costs right now to maintain an offshore wind farm for roughly 5 years. We'll see what it turns out to be for 30 years. And now we're talking about an even newer technology. Do you guys have a sense or a theory about how O&M costs are going to look over those periods of times? Are they lower than wind? Are they comparable? Do we just not know enough yet? I'd be curious to know how you guys think about it.
Yeah, I think starting with offshore wind is certainly a good point. In the US, there are newer wind farms. In Europe, there are already wind farms that are at the end of their life. So you can draw a conclusion that they're being decommissioned. So you get the full 20, 30 year LCOE and O&M cost. So there are two elements of maintenance: is planned and unplanned maintenance. So for new technologies, I think that's where intuitive a lot of people are concerned about is the unplanned maintenance, that unknowns that drive up your cost. And then of course we're designing for these and preparing for these, but then your plant maintenance cost, we actually expect to be lower than offshore wind because we don't need specialized vessels or helicopters, for example. We can be closer to shore. Our solution being fully submerged, we can actually deploy in areas where offshore wind could not deploy due to the visual impact. And so you have shorter travel times. And then our systems are usually floatable like boats. So they're already designed to be ocean going. And so we see a future where with a lot of predictive maintenance, potentially even autonomous and robotics, there's a good future where we can remove any human intervention that drives up cost and have that, essentially units coming back to shore, to harbor by themselves, or doing things robotically and predictively. So all these, and that's where people always ask, why is now a good time for wave? It's all these complementing technologies like yours coming to market, making it cheaper from the full life cycle, from surveying the ocean floor to maintaining, installing things. Cost of robotics, cost of sensors, advanced simulation tools have progressed so much. And that's what we've seen historically in other industries as well. If enough complementary other industries and solutions come together, suddenly you get through that technological breakthrough and hump that then brings the cost down to become really competitive.
So I'm just keeping an eye on the time here. Unfortunately, it's running low. Wanted to open it up to the floor for any closing remarks. Otherwise, I'll just say thank you so much. I feel lucky to have such a great group here to share sort of your collective experience and expertise on this kind of exciting space. Closing remarks. I'll just kind of, whoever feels inspired can just jump in.
It is a very exciting time. And I think, Marcus, you just summarized all of those pieces coming together perfectly. So I hope that more people will start to pay more attention to the space. I also wanted to flag that there is an event next month in Portland, the Ocean Renewable Energy Conference, where I will be with a bunch of my colleagues. And if anyone else is there, please come say hello. We'll be hosting a workshop there as well for investors in marine energy. So I would love to meet you in person. And I was honored to be included on the panel. I'll pass it over to Anthony. Sorry, it looks like I jumped in right in front of you.
It's all good. It's all good. I just want to say, as somebody that is sitting at the front lines of a lot of these projects right now, we have 8 offshore wind turbines in the United States right now, and we are going to be looking to build 3,000 over the next 10 years roughly. And now even seeing where Wave and Tidal have I think a very fighting chance, like they were saying, to compete very clearly against floating wind. What I believe, it's not just about being able to provide more energy. It's the scale and the speed that we can be deploying this at comparatively to any other renewable source at a quantum that is close to the energy users, meaning the coastal environments themselves. This is like one of the largest energy transitions that we're going to ever witness, I think, in the next 10 years. And it's going to be astonishing to think that we had so little of it now. And the grids that will also change because of this. I mean, it's like it's imagining Manhattan before Edison came and electrified Manhattan, right? It's all being rethought and rebuilt globally all at the same time. And there is not enough companies doing enough stuff to try and make this possible. So just as somebody else who is sitting at the front of offshore wind right now, and I'm assuming will also sit at the front of all of these other different technologies, there is a deficit of technologies, companies, funding. I mean, there's all sorts of opportunities. So I'll leave it at that.
Yes, and it's very hard to tell when you're in the middle of an exponential curve, but we are. So here we go.
Yeah.
I think you're absolutely right, Anthony. I mean, floating wind 5 years ago, very few were talking about it. 3 years ago, most of the product developers were shaking their heads and saying it's going to be too costly. And since then, we have seen more than 100 gigawatts of floating wind projects being announced around the world, just gone incredibly fast. And that is what's happening when product developers get involved. They're not interested in 100 megawatts, they're interested in gigawatts. And I think that's the sort of inflection point where we have seen during the last years is we get a lot of interest from the big oil and gas companies, the big utilities and product developers, and at the same time from the end users who want to have the 24/7 renewable energy. So it's really coming together as an industry, which is really, really exciting.
Yeah, very much agree with everything being said. Just wanted to clarify that, of course, we target to be cost competitive with offshore wind and others, but we're not competing. So it's actually the more the merrier. The more projects being deployed, the more cables, the more, the cost of infrastructure comes down. The same vessels that can maintain an offshore wind farm can maintain a wave and a tidal farm. So I think these supply chains, and to the cost question, we're planning to tap as much into existing supply chains from offshore wind or even the wind turbine industry to already benefit from the cost curves on certain subsystems and components. So overall, I think, larger, more adjacent industries coming together will bring down the cost for everyone. So it's actually an opportunity for offshore wind to branch out to ocean energy as well.
Okay, I think we're at a nice closing point and perfect timing. So thank you all so much for the important and exciting work you're doing, taking the time also today to share some of that knowledge and insight with us all. And thank you for the listeners and those joining during the version of the webinar.
Thank
Everyone,
you
have a
all.
good day.
Pleasure.
Thank you.
Thanks for having us. Pleasure.
See ya.
Thank you.
everyone.
Bye-bye.